So very recently, a few weeks ago, was 1.28.0 released. It was maybe a month late, but that's not too bad. The other one, previous release was towards the end of last year, so there hasn't been much time between two releases, which we're trying to keep the time to about 3 or 4 months. So keeping on track there. And the highlights of this release, you can read, these are the release notes just on GitHub. So we've added the PWM finally on STM32, machine.pwm, so that you can very easily create PWM outputs without knowing timers or channels, which has always been a bit tricky on STM32. So, for example, so here is a board, which is just an old Pi board, 1, and machine.pwm, say on pin X1, automatically configures it to timer 5, channel 1, and so you don't have to know the details, but it can do that for you. And all the different pins will have different configurations, and then you can set the frequency to say a kilohertz and the duty cycle to say 50% or so, and that's the same and consistent with the other ports. All the other ports now have PWM, the tier 1 ports, which includes ESP32 and RP2, MIMXRT, SAMD. The Aleph port as well has had PWM added, which is good. So I think that it's been a long time coming and hopefully very useful. The next thing was a new machine.can API. So this has been in progress for quite a few years by Angus, doing a really good job working out sort of what the minimal thing is you need for a CAN API, and then designing the API and then implementing that on STM32 to start with. But it's been done in such a way that it's very easy to extend to other ports, because the actual most of the code is written in a port agnostic way. So the ports can just plug in the low-level CAN implementation, and then everything else will work on top of that. So also he had a lot of really good tests written and documentation. So all of the framework has been done for this. The STM32 implementation's done. So now it's just the other ports that have to be sort of plugged into that framework, and it will all work. So I was just going to demo a little bit about how to use the CAN API, because it's quite simple but powerful, which is good, is what we aim for. Here is the documentation for it. So like all machine classes, you could construct an object, and then you can use it. So I'll show how that works. Right, so I have 2 connected Pi boards here. And is it possible to see? I can stop sharing maybe to start with.
No, it's all right. I'll focus you.
It's not much to look at, but I can. Oh, okay. Yep.
Okay.
So there's 2 boards here, and they're connected to CAN transceivers. So here we have 4 wires, power, ground, and then CAN transmit and receive coming from the peripheral of the microcontroller. And that goes into a little transceiver here, which converts the digital signals into proper CAN bus signals. So this wire here is then the CAN bus in the middle, and that goes to another transceiver, which converts that to digital signals, which then just goes into this other Pi board here. So again, the 4 wires here are power, ground, and then 2 digital CAN signals, TX and RX. So this is the simplest CAN system. Well, apart from a single board in loopback mode, this is the simplest you can do with more than one device. So you can imagine that this wire here is a very long CAN bus in your car or something, and there are many devices connected. So that will, on the left here, I have one of them, one board, and on the right, I have MP remote connected to another board, which you just saw. So we can then make, I I just have some code here, cut and paste quickly. So on both sides, I'll just create the can, import can, create a can instance, and set the bit rate. So the bit rate's 500 kilohertz. And then I can just very easily, well, the first thing I have to do, if I want to send from this side, oops, I have to give an address. So say address 123. And on the other side, can.receive won't actually return anything yet because I haven't set the filters. So I have to set filters. In can, filters are a pretty fundamental part of the protocol. So you can filter on the address to only listen to things that have your address or whatever address you're interested in, or a subset of addresses with masking. By passing none, it means I don't want any filters, so I'll be able to receive everything. So I'll have to send the message again from on the left-hand side here. And then on the right-hand side, I can receive that message. So I got a list with the address that it was sent to, the data as a memory view, and then some flags for some more. You can read the documentation to understand those. But if we want to actually get the data here, so let's try again, send the message. So message, and if I get the first element, it's just a memory view, but if I turn it into a bytes object, you can see it's the message hello. So that's a very simple way to send and receive some messages. We've also got interrupts, so you can register an interrupt. So make a lambda, which is just a function to call, and say I can print I got an IRQ. Oh, I should set the trigger as well. So the trigger will be can.IRQ, say receive. Okay, so this function that I've passed in here will be called whenever a message is received on this side, and it will just print IRQ. So it won't actually receive the message. So if on the left, if I send some data, you can see on the right, it prints IRQ. It's not printing again, I think, because the bus is full. So can.receive. And then there's another one waiting as well, and no more. So it's very easy to make an event-driven system here. So we can also, in that interrupt, we can actually do the receive.
And clear the buffer, right? Yeah.
And whenever we send, it will receive and print the message out. So that's pretty cool. You can also do IRQs on the sender. So print IRQ on our side, and we'll do IRQ TX. So when we send, we should get an IRQ there for the fact that it was sent as well.
Oh, so it passes the can object into the IRQ.
Yes, the argument to the callback is this C is the can object. Yes. And the other things you can do are set filters. So if I do set filter, I may need to read the documentation for this one. So we've got some examples here. Let's just use this example here. We can, oops. Okay, so now when I send, nothing is received because I'm only going to be listening for, so the identifier and bit mask, right? So when you mask the incoming address, with this mask, it has to match this value here. So if I send it to something like 301, it should come through, yes. Or if I send it to 700, it'll also come through. I can send it to say, it should ignore, oh no, it's got to match everything, yeah. So 302 won't get through. But if I changed it to say set filter and ignored the lower nibble, then when I send 302, it should, no, that doesn't come in. 301. I think maybe if we go back to the F. No, okay. I need to probably reset the bus. But you can see the filters can be used to mask up certain addresses, and there's also extended identifiers, so standard addresses are only 11 bits long, but extended values 25 bits long, I think. 16.
And that filtering happens in hardware on most devices. Is that how that works? Or?
Yes, that will usually always be in hardware.
Yeah.
CAN peripherals are pretty, because the CAN spec is quite standard. The implementation in many microcontrollers is very similar. So they're the main methods, really: send, receive, and set filters and IRQ. There's also some further ways to configure it for the timing, the sample points, and also, I think, to get more status about the bus if it has errors. Cancel send, so state and get counters. So I wonder if can.state here, which is active, I think. And the counters should tell us, error counters, number of error receive or send, transmit, overruns, and pending messages. So there are no pending messages yet. So that's, if I do send from this side, this doesn't have a set filters, none. So here you can see there's one message pending for the receive. If I send another one on this side, there's now two messages in the FIFO waiting to be received, because I haven't set an interrupt here to, or I haven't received them yet. But if I do can.receive on this side, then there's one left. And if I do receive again, there should be, that was the second one. And there's none left. All right, so that's CAN. It should be available in the next release on MIMXRT as well, and maybe Aleph. Would be good to get it on ESP32, because some parts do support it there, I think. And API2 does not. So I don't know how that would work. Maybe someone could write a PAO implementation, but probably not worth it. So just to finish off with the other highlight features, template strings and weakref module were added. Now, these aren't actually enabled in many ports because they're quite large, and we're not yet sure what they're useful for in a microcontroller setting, but they were mainly added for the WebAssembly port for use in PyScript, so that when MicroPython's embedded in a web page, it can use these features. We'll quickly demo them. So have to use the coverage versions of MicroPython, which has them enabled. So a template string is like an F string, except it produces you the unconcatenated version. So here it's just the string, but if I add something in here, like X, which is a variable, now it's going to say name's not defined, because it's similarly, if I made an F string, that would also not work. So if I define X to be 1, 2, 3, the F string will have X interpolated inside that string. And if I make a T string of exactly the same form, it creates this object which has the ABC and the DEF separated, and then the X interpolated as 123, but it also tells me what the expression was that was alpha evaluated and any formatting string that was used there. So I can access this and get the strings as a tuple, and the values, and the interpolations is like the more detailed. But if I wanted to join it all together, I could do, well, yeah, you'd have to insert the value into the string tuple. But you can see how you could reconstruct the F string very easily from this object.
Mm-hmm.
So MicroPython's T-strings match CPython very, very closely. Nested T-strings are supported, and pretty much all the features, just very few minor little things like we don't support ASCII, repr, but ASCII doesn't work. That's one of the only things. And then I think space after some formatting, but it's very close. So T-strings, if you're interested, you could enable it on a port to use, or maybe we can, I think actually maybe some ports like the MMXIT with very big boards do have it enabled. The other feature, the weakref module. So weakref is allows you to hook into the garbage collector when it runs. This is a CPython feature which is implemented in MicroPython, and again, like T-strings, it's very the compatibility to CPython is quite high. It matches the semantics very closely because you need to get them right for it to work. So weakref will .finalize is sort of the user-friendly one. There's weakref.ref as well, but let's just use finalize. So if I pass it an object, say a dictionary, and then a callback, I can't remember if it takes an argument, but collected, say. Okay, so that callback will be called when this dictionary gets collected by the garbage collector. And because no one's referencing that, if I do a force of collection, it should free that dictionary and print the call my callback. Okay, so it did, but I should not have an argument there. So let's try again. Yes, so when I ran the garbage collector, it collected this dictionary because no one was referencing it and called the callback. So you know it's been collected. If we instead hold a value to the dictionary and try and finalize that, gc.collect, obviously it's not going to call it because I've still got the dictionary as a variable here. But if I do d is none to clear it, then there we go, it collected it the second time. So this is a safer way than having _del implemented on types, which has a few little sort of foot guns implementing that. But the weakref.finalize is quite a well-defined way to hook into the garbage collector if you need to. Again, this is not enabled on many ports, but if you find a need for it, it's there in MicroPython now. So they were the main headline features. There's lots of other things you can read about in the release. Maybe notably in MIMXRT, there is now machine counter and encoder classes, thanks to Robert. And there were quite a few new boards added. Lots of RP2 boards that were sitting there as pull requests for a while that finally got in. And a U5 board for STM32. So yeah, that's about it. As usual, lots of people have contributed from many time zones around the world. And you can read about all the details here. And then you can see we've already 70 commits already since the release. So lots of work goes on in MicroPython.
Cool. So we've got 1.29 coming in then, what, 3 months-ish?
Yeah.
Is there anything that you're sort of gating that release? Anything you're sort of targeting specifically?
Not this time. It would be great to get the PSOC edge port in. That's kind of what I'm targeting, but it's not a release blocker sort of thing.
You can see Julian's here, so yeah. Yep.
So
working on it.
No pressure, but
No pressure.
that would be really good. It's a really nice, very nice chip. Lots of and the dev board's really cool as well. So yeah, excited to see that go in. There have just been lots of, there's always lots of things going on and lots of contributions. So some of Yoss's MP remote fixes and would hopefully be good. And I think Robert SamD's read timed, write timed for ADC and DAC. They're all that's pretty close to going in as well. Yes.
Sharing the milestone, which has some of those features listed already. So yeah.
Yes, the milestones I try to keep up to date. I haven't put a date on that yet, but yeah. Oh, there's a whole bunch of things that need updating, like the IDF. Hopefully the Pico SDK has a new version. Tiny USB needs updating. Zephyr needs updating. MBTLS needs updating. Little FS needs updating. Yes, lots of submodules need updating, and that alone takes time. But also Octoprobe and testing still ongoing, still improvements all the time. More tweaks to the test suite to make it run better and more efficiently and on more targets. And then with Octoprobe, still trying to get a suite of boards working there so that it's efficient and reliable. Currently, there's about 100,000 tests that are run on Octoprobe now, which takes about 13 hours. That's because it's run in serial, not parallel, because in parallel it's a bit of reliability issues at the moment. But yes, 100,000 tests across, I don't know, I think it's 14 boards or something. And we have only, I think, just less than 200 failures out of that. Maybe 150 failures in 100,000 tests, which are like consistent failures. It's not random failures that just need fixing. But still, 150 failures is too many to have something that you can look at. Like when you make a pull request, did I break anything? If there's already 150 failures, it's hard to know if you broke anything. So the aim is to get that failure rate, the failures down to 0. But the last, 1%, 0.5% is really hard.
13 hours might be a bit much for a PR gate too.
Oh, sorry?
You might not want to block PRs for 13 hours each either.
Yes, of course. Yeah, that link Matt gave, that's running on master. Yeah, so 285 errors, 100,000, almost 100,000 tests.
Yeah, it's cool.
I have it. Yeah.
Cool.
Hans shared it, and it's great. It's lots of stuff.
Yes.
Yeah.
I mean, when it runs in parallel, it takes about an hour and a half. That's still a long time, but the idea is that you just manually trigger it for any PR you're interested in. The report will come, later.
Yeah.
I need to get some of them set up.
But yeah, it's very, very useful to know, just to run it across all hardware targets that we support, and because the tests can now run PWM tests and I2C tests and SPI tests and UART tests and everything. So it's really great to know when those things are not broken.
Hans, if you're listening, could you share the link to Octoprobe for those that may not have come across it? There's a few new names tonight, so if you could pop a link into the chat window, that'd be really helpful to do so.
Oh.
Image in the chat, but no, I can't.
And then
I did take a photo of my hardware in the loop test setup, and it's not as neat as an Octoprobe, that's for sure.
Gotta get you some Octoprobes.